So this is what we call the shallow water model. It's an approximation. It's the most basic approximation of the dynamics in fluids. We assume that there's a layer of fluid and it all moves at the same horizontal velocity, lateral velocity. So that's the assumption behind the shallow water. And this sketch shows you the configurations. You have an undisturbed sea level called H0, but the total water depth can change in the model domain. As you can see here in this brown, we're actually getting deeper here along the X. And what we do is just considering a one-dimensional channel. Okay, it's easy to actually add another horizontal dimension to it. Okay, it's just one dimension. Okay, and the assumption behind that is this type of model is justified if the horizontal wavelength of a process exceeds the total water depth by far. Okay. All right, so we have something called the sea level elevation, which is the difference between the true total water depth to the undisturbed water depth, sea level elevation, with this symbol here called eta. Okay. We have the horizontal velocity, which is the same throughout the water column, called u. Okay, and we call it a velocity because it can be positive or negative, which is different to a speed. And then indeed, just mentioning, we have no density stratification. The density, which is weight per unit volume, is the same everywhere in the. And we have a free sea surface. The sea surface can change. So the governing equation I've written down here is we have a momentum equation, which is the first bit, which tells you if you have a force on the right-hand side, results in an acceleration, which is on. And the force is associated with a horizontal gradient, a slope of the sea level, which can be positive or negative. And the second equation is an equation that expresses volume conservation. And you can see that these equations are coupled. You know, you have the sea level on the right hand side and the left in the first equation, and you have the horizontal velocity on the right hand side in the. So this is what we're talking about, and we want to simulate this. This is exactly what we want to simulate, all right? Okay,